Hello, and can everybody hear me? Can you hear me? Hello? Testing, testing, can you hear me? I'm going to blather until somebody tells me they can hear me. Okay, cool. Alright. This is since we're right on time, I'm going to go ahead. This is the web workshop. You should have downloaded the Git repo that's referenced off of the Moodle page, and you should be if you will start this with SWPL debug.pl. This will do a bunch of things. This, by the way, is a pretty common thing I do. Is when I'm working on a project, I'll have it automatically start up kind of with my environment where I want it to be. So it goes ahead and fires up a local server, and then it calls www open URL, which opens the browser to a web page. So it'll open 3 web pages for you. This workshop is a hands-on workshop. It's given from it's driven by my notes on this page. Localhost 7777/workshop. You can kind of follow along my notes here. By the way, it's actually a planner. Every time I click done, it assumes I've finished a section, and then goes ahead and replans to get the most value. If somebody has questions and we get off topic, that gives me the flexibility of not worrying, because it'll replan my talk for me dynamically, and it knows about things like I actually have to talk about this to talk about that. So, okay. Go ahead and open debug. Things have changed slightly since this was written, and you now have to respond to the question with a 1 or a 2. I responded with a 1, and here's debug. So I'm going to assume everybody actually is running. Presumably all have a working SweProlog installed. And all right, in SweProlog, when you want to write a web application, you make yourself a web server. So a very typical arrangement would be to have the web server be running on a high port and only accepting connections from localhost, and then to front it with Apache. Apache's very good at dealing with various sorts of attack, and you don't let on too much that you're using Prolog and so on. So it's a pretty common way to do this. Also, if you want to run multiple services, on port 80, this is a way of you can vhost some sub URIs. So, okay, when you start a major Prolog application or system, this is a pretty standard sequence of things to do. As applications get large, loading things just on demand makes you vulnerable to hard to find bugs that involve load order. So a very typical thing to do is to have a load.pl that actually loads all the modules. So usually I'll make a debug.pl and a production.pl, and to run the system in debug mode I run debug.pl, and to run in production I run production.pl. Either one will at some point then run load.pl, load the modules. In debug, since I'm going to run the doc server so that I can have handy PL docs while I'm working, the doc server is going to start up the web server, and since you can only run one per VM, I let it handle the actual running of the server. If not, in production I have to start the server. So either way, I end up loading strangeloop.pl, which handles the core utilities. And then I have a bunch of modules that define handlers, and then I have, utilities and back-end stuff. And that's the structure of my application. Okay. All right. Let's look at what happens when you start this up. You'll generate a bunch of info. This is a fix for a long since dead bug. And then we'll just define a whole bunch of stuff that's useful for debugging, and doesn't look like my file. Hang on, that's not my file. Okay. I want to edit debug.pl. Sorry about that, folks. 2. I should have picked a 2. Okay. All right. So, all right. We're going to first check to see if we're on a reasonable version. And we have a helper predicate that defines that. Flip portray on. Ensure that we're in the right working directory. So if we start from some oddball place, it fixes that for us. And then we define a location. I am going to talk about those in a few minutes. And then start up the documentation server and start up other stuff. Okay. The next thing that will happen is I will load, and I will then make certain that first my server comes up, and then all my handlers get installed. Now, when you start a server, you use HTTP server. You pass it a dispatch predicate, and you pass it a bunch of arguments. And the dispatch predicate, there's only there's only actually 2 reasonable values to pass it. One is HTTP_dispatch to get normal dispatching, which is what we'll do here. And the other is to pass it Rivo's simple router Rivo has written an alternative to HTTP dispatch. Likes better. Rivo is awesome. If you ever get a chance, like, introduce yourself to Rivo. Let me find my pages here. Okay. All right. One thing I should say about this actually is I have what this does is it moves PLDoc off of the root. It moves it into help source. So URI path so that we can use root. That's a little nuisance that it by default comes up. Okay, and I guess we're at the point of talking about abstract URI path. If you've ever built a large web application, you know that sooner or later you're going to have to go through, find all of the URI paths and change them to something because you realize you need to have that tree of paths be organized differently. So this is a real pain in the butt, and to avoid this you can define this HTTP location, which is a multi-file predicate. You can define an abstract URI path. This is an abstract path. It's a little bit like a file path, but don't an abstract file path in philosophy, but don't confuse the two. They are different. This is an abstract path, which in this case is defined relative to the abstract path root, which always starts at slash. And so root help source, so slash help slash source, is going to be defined as the root of the PLDoc tree. So if I say PLDoc open paren foo foo slash bar, then I am going to get slash help slash source slash foo slash bar. Okay. All right. So that is the abstract path system, and we'll see a lot of it here. We've already covered, I believe, abstract file paths, right? I sure hope so. Abstract file paths are... somebody say something if we did not already cover abstract file paths, if people want me to cover it again. All right. Okay. Once you have your basic server environment up, you then just define handlers. And I'm going to... I brought my navigator up, and I'm going to... let's look at simple handlers. Okay, yeah, I already covered abstract file paths. So abstract URI paths are pretty much the same. I would say that an abstract URI path you can define in terms of another abstract URI path. So that is a difference with file paths. All right. You'll notice this module actually exports nothing. This simple handlers, which you probably should look at, is a implements some simple pages. So let's go over here to, for example, it implements the root handler. Whoop. Sorry about that. that says hello world. Okay, here I did not use an abstract path. I just used an absolute path. Notice that it'll be happy if you use slash as an operator. The way you the way you define a handler is simply call HTTP handler, which usually you would do as a directory. And you pass it a predicate, which does the actual handling, and then you can pass it some options. In this case, I bumped the priority up to make certain that this one handled it and not PLDoc, and I made certain, and another common thing to put in here is you can actually provide this handler an ID, which is also convenient because you can then later on get the relative path that gets you to this handler. Get the URI path that gets you to this handler. Okay, so I'm going to call this say something. Now, say something is called with one extra argument. Notice here it's got one argument. Here it's got two. And when you bind, or when your handler is called, current input is bound to input from the socket, and current output is bound to the socket. So this is the crudest way of making a page, is to just print it. There's one request that is, or one header that is required in HTTP 1.1, and so you're going to have to print that header at the very minimum. And here we've just said content type text plain, and then whatever was in our argument, we will print that world. Okay? All right. Since this is a pretty simple scheme, that lets us dink around with special situations. For example, I can have hello in German. And the way I define this is that I define this predicate howdy handlers, which is going to get howdy, and I have hello in a whole bunch of languages, and I get that out of the fact, and this is a repeat fail loop, you'll notice. I then form encoded, because you need to form encode path segments per the spec. I will then make the path up, and then I will call HTTP handler. So here we're already doing something that might be difficult in some other scheme, in some other language. We're automatically generating a bunch of handlers. And here we're going to have a closure, right? Because howdy will be bound. Everybody following me? Everybody happy? So I can go back and I will say hello in, let's say, Kansan, since I used that example last time. And it says howdy. And so, questions about setting up handlers? I said it was called with one extra R, and I didn't say what that was. That's the request. It comes in as a list with kind of all the usual information you'd expect in a request as compounds within it. Later on, we're going to look at how to get information out of it, but its structure is pretty simple. You can just grab it with member if you need something special. Okay. Let me get back to my drop sheet. Oh, there it is. Okay. All right. This is a hands-on workshop. Whoops. Mic fell off. This is a hands-on workshop. So we're going to take a few minutes here, and everybody, I guess, say hello to yourself. So why don't you add /hello/your name by implementing another handler, and then you can have it say hello to you. All right. So I'm going to take a few minutes here and be quiet while you all do that. And folks, say when you're finished so that I'll know when to go on. How are people doing? Everybody getting, I'm not seeing folks say anything, so I'm assuming everybody's over there furiously puzzling this all out. Having trouble? Go through this too quickly. everybody there. Reacting to the lack of feedback. Guess it's only been a few minutes. Okay, cool. All right. I see one done. I'll wait a few seconds more. Okay. Yeah. Hey Alexa. Cool. Okay. I'm gonna give people a few more minutes to fiddle with it. I don't get it. I'm of course sitting here with no feedback, so I may be. I'm not an overly patient person, so. So yeah, you can use this as a template for. No, you won't need to. We're going to talk about that next. Most of the time, it generates all that for you. I just wanted to. Okay, all right. Yeah, most of the time it'll generate it for you. I just wanted to show you what was kind of under the covers, so that you're not voodoo programming. Okay, I'm going to assume we got that working, and I'm going to go ahead and talk about the HTML generation sequence. Okay, this is the normal way of doing it, not printing out your own headers. An HTTP sequence comes in, it goes through HTTP dispatch. Remember, this is that predicate that we passed to the original call to start the server. HTTP dispatch gets called with all requests and figures out and basically then goes and finds your handler. So it'll call your handler predicate after building up the request as a Prolog term. Typically, then you would, extract those parameters and check that this is an allowed call and do all of those kinds of things. And then and then you'll call reply HTML page. And if, let me see, I think I have fancy handlers. Yeah, so if you'll open the file fancy handlers, you can see here's the zippy handler, and reply HTML page takes a pair of arguments, and those are in what we call termerized HTML. There's at least 3 representations of HTML in Prolog, in Sweet Prolog. One is just as a big string, which we try and avoid doing because you've of course got no syntax checking. But if you need to be doing that, like if you got a piece of boilerplate, there's a Quasiquote. A second is you can take a list of little pieces like tags and closing tags and chunks of content, and it will attempt to lay those out and print them. That is tokenized HTML. And then there is a sophisticated DSL for representing HTML. And then so back on our workshop page, we'll see, we call reply HTML page, and we pass it 2 pieces of this termerized HTML. Notice that each one is a compound, and that compound is a tag, is an HTML tag, and then its contents. Okay? So, now, this will be what goes in the header, and in this case we're just setting the title. And then this will be what goes in the body. However, fortunately you do not have to stick the entire body in there, because there is an encapsulation mechanism in this termerized HTML DSL. So a very typical thing to do in here would be to put a single encapsulation, so-called inclusion. Okay? So we will generate a bunch of this, and then it will get converted from termerized HTML to tokenized HTML. After that, you can apply styling. If you have common elements on all of your web pages, you can define them in one place. Then it passes through the mailman system. The mailman system is quite nifty. It allows you to designate a place in your HTML and then generate that HTML somewhere else and have it mailed into the appropriate place. So, for example, say you have a long web page and you have a header and a footer that's different on every page, but you have menus that kind of depend on the contents of the page, but the page is long enough that you want to have it these menus repeated at the bottom. Well, your life will be easier if you generated those up at the top and mailed them down. Similarly, if you're doing something like putting a count up at the top, it's easier to count while you're getting stuff out of the database and then mail it up to the top. So Mailman's cool. And then there is a thing called print HTML, which attempts to lay out your, by this point, tokenized HTML and turn it into a string, and then finally it'll send the outgoing response. Okay. All right. So that's the sequence of generation. Questions about this? We'll go into detail on all of these parts. Okay. there are kind of two camps of HTML generation. One is you build kind of a template and then stick the dynamic parts in. This, of course, has the advantage that the front-end folks have their own tool chain, and it works better with them. But and so this is what, for example, JSP and ASP use. And in fact, how does back to the response without the response being an argument of the Brian, it prints it. Reply HTML is ultimately going to call going to cause the rest of this chain to happen. So so all of this is going to happen in reply HTML, and it'll just get printed to standard out, or to current output, which is bound to the socket. So that's where it'll go out. Okay, let's move on to I've answered your question. I'm going to move on here. There are these two camps. We're pretty much in the generate HTML camp, and then we provide you with some ways of getting out of that if you've got a bunch of boilerplate. This DSL is actually a DCG, so it's going to generate the output using a DCG you supply. So there is a DCG called HTML//1, and if you open up HTML handlers and then look at okay, let's look at for example lots of syntax. We'll be at lots of syntax for a while. So browse lots of syntax, and you'll see we get all this stuff. Now it's a very simple HTML reply page. This syntax is what's called an inclusion. We pass it the name of a DCG with a backslash before it, and it will go ahead and expand the DCG in that spot. So here's syntax demo. Notice it's a DCG. And I wanted to demonstrate using some variables, so I set some variables to some constants here. And then I am going to call this HTML1, you know, that's //1, it's a DCG. DCG, so that I get tokenized HTML back, and I pass it termerized HTML. I do not need to generate my own body tag or HTML tag. That is done for me by reply HTML page. We'll revisit that later, but for now we're just generating the contents of the body. And in this case, my body is a bunch of tags. So I pass it a list. If you pass a list of things, it just concatenates the generated HTML. So here's a tag that only has, so all of these tags are either arity 1 or arity 2. If they're arity1, their contents is is the contents of the tag. That is between the P and the /P. There's a bunch of text. So this does kind of what you expect. And you might want to hit Control-U and look at the source to this page. Here, I needed to bold a word, so I used a list. So here's some text, and then the bold, and then some more text. So, are everybody up with me? Everybody got where we're going? Okay, this next one illustrates what you need to do if you need to put things as attributes in the tag. Here I have a style attribute and a title attribute. So if you give us a tag with, a compound, a tag with arity2, then the first one is going to be a list of attributes, and the second will be a list of contents, and then the attributes have their own kind of specialized DSL. Basically, you can have, attribute name, value, you can see. Okay. All right, so this, you'll notice, comes out as this. It's going to do all the scaping for you. So this does not generate tags, and if you need to do that, this is one way of doing it. The other way is a quasiquote, which I'm going to talk about later. So if you put a backslash and then a list, everything inside the list gets literally transcluded. Okay, if you need an entity, like in this case a copyright symbol, you can say ampersand and a copyright. The syntax is designed to make your life easy. It supports the atom minus list style of format representation. So you can say, if you need to do some kind of formatting, you can do it right in line. There are, on the attribute side, you can make a URI and use name, key equal value pairs, and have it make you a search string, and it will properly encode that for you. If you want to manually encode a message, there's an encode. So for example, here it's not going to realize that it's a key value pair, so we have to manually encode the message. This is kind of cool, but in the handler, if I go back up, remember that in the options, one of the options you can add is an ID. So if you add an ID, you can then get an href by saying location by ID and referring to the ID, and you will get, and wherever that handler gets moved around, it will take you there. By the way, there's a cool little thing with edit. If you are working on a web application and you say edit and a relative URI path with slashes in it, then it will take you to the handler definition for that URI path. So that can be really cool. All right. Class is handled specially. It understands what to do with a list of classes, and will make the appropriate, string with spaces. Okay, and that brings us to inclusions. Any questions about the ones I've covered so far before I move on to inclusions? Sorry, the latency means that I have to wait a little while. All right, seeing none. Okay, here's the definition of an inclusion. It too is a DCG. And then as long as you're, and then remember that we're actually on the tokenized HTML side of the world. So when you enter an inclusion, you're in tokenized HTML. You'll need to use HTML1 to get back to of using edit with the handler. Sure. Okay. Edit. This, of course, happens to be named that, but what it actually did, I tell you what. In fact, let's here. Notice that this one's not named Hello German. So what it's done is it's figured out that I registered a handler for Hello German. It just calls the dispatch code and says, okay, what handler do I have? And then it says, oh, well, you're going to end up and say something. And then it takes me there. So, all right. Okay, so back to inclusions. All right, so when you put an inclusion, you are back to the inclusion should be generating tokenized HTML. So in this case, fine, I am going to have the inclusion match a set of two different other inclusions, which means I can just, since it's a DCG, just define it as being one after the other. And then each of those, I actually want to make some tokenized HTML, so I'm going to call HTML1. Okay, that's an inclusion. Now, inclusions do one great thing for you. You can build some encapsulated content. If you have a login box on every page or a search box, you can make the search box be an inclusion and then just stick it in. And then if you ever have to change the HTML generated by the search box, you only have to change it in one place. Okay, so here's a trick. suppose the styling on your site is such that you want to have some kind of fancy dotted borders around things, and it's not really handled well by CSS, and so we're going to generate, some kind of little border. Maybe we have draggable widgets, and we're going to generate all the draggable widget stuff. That's probably not a good task to be done in pure CSS. So let's build a thing, and we'll pass it a style, and then we really want tokenized or termerized HTML in here, right? That's kind of what we want to be able to pass, so that I can just make this thing an inclusion and have it be a normal part. So this is meta programming in the little DSL. Okay, well, there's one little problem here, and that is, let me make certain I'm on my topics list here. Yeah, inclusion. Okay, so there's one little problem with this, and that is, this is going to work fine, except except that I, of course, wanted to do, I want to be a good software engineer, so I stick this in its own module, right? I have the fancy borders module, and fancy borders takes its contents and then just passes it, to and then makes a div that it styles, and then just sticks the contents in there. Well, if I comment this line out, well, let's think about what's going to happen here. Okay, in HTML handlers, I'm going to call fancy border. Well, fancy border, since I've imported the fancy borders module, is going to resolve, right? It's going to module resolve, and then it's going to pass this. But we're not in Prolog, so this is not a module qualified term, and I'm just going to get backslash, what was it? An inclusion. It's then going to attempt to resolve that, but notice that I have not included, I have not done use module on HTML handlers here, and it's going to fail the module resolve. So let's comment this out, rebuild this, and then I will go back and I will attempt to reload this page, and I get an error. Okay, what's it say? Undefined procedure. Fancy borders module and inclusion 2. So we need some way of warning it that we need, when we pass things in, to expand any inclusions that with their module name. And the way we do this is we use this directive HTML meta, and then we say fancy borders arguments are, and we use the usual symbols, but we have one extra one, and that's HTML. So for example, here my style just comes in as a plus, right? That's the mode for it. And then the next argument, however, the contents are HTML, are termerized HTML. And then because of the DCG, you always have to add 2 arguments. So here we've added 2 arguments to represent the DCG. Okay. By the way, that also makes certain we get syntax coloring back over here in, if this was complicated, we might be really glad we're getting syntax coloring and syntax checking here. So, okay, I should be back running. That fixes our problem with modules. Okay, questions about inclusions. Inclusions are very cool, but you can get bit by this module thing. There's one last thing to be done in HTML handlers. Quasiquotes. I don't know where this thing is in the... yeah, okay, quasiquotes. All right. Questions? Hearing none. Okay, this last one. Let's say we got a whole bunch of boilerplate, like, you know, we're sticking in the Amazon the Google Analytics code, or, you know, somehow we've just got this chunk of HTML. I don't want to manually translate that into termerized HTML. So there's something very cool. I can get it. I can get that done for me automatically by something called Quasiquotes. Quasiquotes are a language feature of Sui Prolog. You can write your own quasiquoter. If we get time next week, we might actually cover this, how to write a quasiquoter. But basically, you can be chomping along in Prolog and then say, okay, and now I want to express myself in some other language. So I will say, open curly bracket, open OR bar, then the name of the language of the quasiquoter, which is a compound term, and a series of arguments. It's just an atom if you have no arguments. And then two OR bars, and then from there to the next OR bar followed by a close curly. Everything inside is interpreted by the quasiquoter. So in this case, what it's going to do is it's going to give me a bunch of termerized HTML, and then notice I pass it through HTML to get what I wanted. Inclusions, a general Prolog. All of this material is specific to Sui Prolog. Frankly, I don't know of any other Prolog that has a very well developed web framework. So basically, if you're doing web programming in Prolog, you are doing web programming in Sui Prolog. Yeah, to be honest, this is a very nice web dev system, and most of the other Prologs kind of say, okay, and here's a way to write out to a socket, or sometimes to an HTTP request, but there's not nearly this level of support. Yes, inclusions are specific to web development. Inclusions are part of this DSL that is ultimately always passed to HTML1, the HTML1 DCG, to convert into tokenized HTML. I suppose somebody somewhere has figured out some handy other use for them. I can imagine if you're generating complex XML documents, I mean, but that I kind of think of as web programming. But basically, yeah, inclusions are not a Prolog thing. They are a termerized HTML thing. And yeah, be careful. You are not in Prolog here. When you are working with this termerized HTML, you are in a DSL. So it will for example, not do module resolution automatically. Okay, so this is using quasi-quotes is actually a far better scheme. Remember that up here I said you could include stuff like this. This is kind of evil because you've broken your guarantee that what is generated is valid HTML. One nice feature of the system is it works very hard to enforce generating valid HTML. Okay, so, all right. Mailman. You open the file mailman, and let's look at /mailman. Okay. All right. Let's say that we have a bunch of information that we're only going to know at the bottom of the page. Okay. And in this case, my information is just going to be the paragraph. This will be at the top. And I want to stick that up at the top. Well, ordinarily this would mean you'd have to like do some pre-computation or something, and it'd be a little ugly. I can even imagine people like generating some JavaScript to have the JavaScript stick the contents in. You know, it's just going to be messy, right? And we've all dealt with this problem of your code's organization gets dictated by the order in which the page is generated, and that's not always convenient or and doesn't encourage clear code. So, okay, so here's a handler where I can move stuff up to the top from the bottom. All right, here's some pretty ordinary looking termerized HTML, and I have this inclusion, which is a library call, HTML receive, and I give it an address, which is just an atom. So I call this mailbox top stuff. And then down here at the bottom, I'm going to call some inclusion, and we're pretending that we don't actually have the information we need until we get all the way to the bottom, right? So we've generated all this other stuff, and maybe it's the count of the number of things we generated or something, but we just don't have it yet. So fine. So now what I'm going to do is I'm going to call another inclusion called HTML post. And this is a meta inclusion whose second argument is some contents and whose first argument is an address. And when I finally generate my page, whatever I posted will be transcluded up to wherever the HTML receive is. And I could post many times to one address if I chose to. One thing you might need is, suppose I am dynamically generating the title and I don't know it until sometime down in the page, which might be pretty common. For example, I might be doing a database lookup on on some key, and then generating a page of information. I'd like the title, which is going to set this up on this tag on the top of the browser. I'd like that to be generated after I've done the call to the database to get the data out. And so there is an HTML receives. There is a mailbox called head, and conveniently you can mail stuff into the head. This is also really handy if, for example, you want to dynamically generate a little JavaScript. You can stick it in the head. Or if I'm making an inclusion, there's actually a couple of ways I can do this. One way is I could mail the meta tag to get the JavaScript inclusion, although that's actually not as great as what we're going to talk about next, which is the resource system. Okay, questions about Mailman? Okay. Fancy handlers. Yes. We go back to fancy handlers. I've set up here an abstract URI path. Okay? So in this case, I've set /f to serve files. If my website is mostly involving, if my website's going to serve some random files, who knows? I have to serve Excel spreadsheets or something. So I want it to do what Apache does, right? The Sweet Prolog web server does not do the usual thing of having a root and then serving files under it. By default, you have to, if you want that behavior, you have to build your own little handler that does it, and that's what I'm talking about doing now, is how to do that. So, okay, I'm going to make an abstract file location called files. Now, I'm going to make a file search path, which in this case is just /assets, right? And then I will make the abstract name of an array path. I will make a handler. So I will have files, and then it's going to call something called serve files. That's right down below, of course. And then I'm going to give it the option prefix. If you give something the option prefix, it establishes a handler not only for that array path, but for all array paths under it. And in this case, and then there is a handy library predicate that will actually handle doing this, right? So I can just say, notice I have a file search path here. I can give that file search path's root, and it'll just serve files. So for example, if you've got a bunch of boilerplate HTML, you could just serve a bunch of HTML from under it. And it will use the extension to attempt to figure out the MIME type. Okay. Now, if the file is not there, I add a second clause, and if the file is not there, then a 404s. And there's, a canned routine to generate a 404 page. I might choose to generate an ordinary page with reply HTML. Reply HTML page. Okay? So that, I could just say not there or something. All right? Let's talk about the little challenge here. Okay, your site's gotten fairly large, and we're realizing we need to have some way without kind of bringing the site down to just be serving a nice, something the web designers designed for us that says the site's offline. And then presumably from some back end we would flip that on and off. How would we go about making that happen? And yes, there is a remove handler function if you want to abolish a handler. So that's how it would get rid of it. But what would a handler look like, right? We just install a new handler. Anybody? Are people lost? Am I talking to myself? Okay, so I'm not seeing anybody responding, so I'm going to. So what we need to do here is we probably want to. We just need a handler that handles everything, right? That will temporarily assert. Yeah, that's a good tactic, but I don't think it'll work. Alexa, that's a good thought. You can't actually define an HTTP handler against an undefined variable, unfortunately. Yeah, Pescuma, right. And then, yes, Pescuma, you've pretty much got it right. You would install a handler on / and you would call it prefix. So it'd get everything, right? Because everything has to be under /. And then you would have it, generate a HTML file, however it did, and you would set its priority very high, so that it definitely was the thing that was serving everything, and that would take the whole site offline because every request would be redirected to that. And then, yeah, later there's some remove HTTP handler, so we could get rid of this thing. You'd probably give it an ID. I believe you have to have an ID to remove a handler. Okay. All right. Styling. Remember I said that on the way out you could apply styling. So, for example, if we look at the page styled, if you look at I'm looking at stylinghandlers.pl. If you look at the style, well, this is a simple page, and then if I ask for and you will notice in this thing that I just generated a paragraph. I didn't generate a header. Okay, so where does the header come from? Well, I have defined this multi-file DCG. That's a multi-file predicate. That's a DCG, and it takes the name of a style, and then it's going to take a bunch of content that is the body, and then if you do this, you become responsible for making the body tag and any contents. So, for example, if you need to influence body attributes in the body, this would be a way to do it. Okay. Have I not? Yeah. Okay. There is a similar one of these for head. And this can be a real lifesaver in terms of making your in terms of reducing complexity, because you're not generating a bunch of boilerplate all over the place. Okay. All right. So, all right, that's styling. We're just cranking through this. Any questions about styling before I go on? Well, so far we haven't done anything with the request. We're pretty much ignoring that. So, we need to handle requests, and so you can get the parameters out of the request with this HTTP parameters call. You pass it the request, and then you pass a bunch of partially bound terms of a form argument, and then this is where it'll actually bind the name, and then you can add a whole bunch of constraints to validate your arguments. So that's fairly straightforward, I think. I will leave it to you to look in the docs to understand these arguments, because you probably won't remember them. However, there's one very cool thing you can do. Where is that? Params once. You can call HTTP parameters, if you look at params once, with an additional argument for options. one of which is attribute declarations and a name. This is actually expected to be an arity2 predicate and will give you the argument key and the argument constraints. So if you're writing some big system and you've got a whole bunch of places where the constraints are that take all the same argument, you can use this system to just really vastly simplify your life by defining what all of these constraints are in one place. Okay, and here all I've had to do is just define, what arguments I want to get out. Questions about that? Just a way of binding all of those, constraints back to all the argument options back to the arguments without such a mess. And by the way, yes, it will do things like do name to atom conversion. Okay, that's about what there is to say about parameters. Resource inclusion, if you'll look at resource demo. CSS and JavaScript are things that we quite often want. Yes, each constraint is a list of terms. I will go back to that. Yes, the options to a single argument are a list of terms, and for example, you can say optional true, which means it's permitted to omit this and leave it unbound, or you can say default and give it a default. You can insist that it be of length greater than 2. If you say integer, it will be converted to an integer. It will enforce that it is an integer. And then and of course, if you're handed invalid stuff, it will fail. So you really should probably have, be prepared for HTTP parameters to fail. But yeah, each constraint is a list of terms. Let me go back up to the here. I've used an arity2 term for the title here, and I have the default defined. I've got options right in the HTTP parameters call. It's just this gets repetitive, and avoiding repetitive things is good. Okay. On versus Brian, tell me if I've not handled that. Okay. All right. JavaScript and CSS are going to be things that you're quite often going to need from several places. Gosh, if I'm down in some inclusion and, hey, this inclusion requires this special little piece of CSS, then what I can do inside the inclusion is I can call this inclusion HTML requires, and then pass it. This could be a file. It can also just be an abstract name, just an atom. And So for example, if I go back, where does this land? Resource demo. Resource demo. Okay, this has gotten this really ugly styling on it because I requested that special style.css be included. And if we then do Control U on this page, which I'd encourage everybody to do, then you'll see that it's included 2 style sheets. So where did grad style come from? Well, we then can define a resource. We'd say HTML resource, and in this case it's a, an abstract path, requires this other, and it in turn requires this other resource. Frequently, for example, if I'm using jQuery, right? I know jQuery is on the way out, but if you're using jQuery, I will define jQuery, and then I will use the option virtual here, and then require the actual jQuery file. You can also define, by the way, the MIME type so that it does the meta inclusion properly, and it will figure it out from the file name if you don't. But occasionally you run into JavaScript files that are not named .js. This system, if you do this, one thing that will happen is you won't end up with multiple links, with multiple links to the same thing in your head. And you can actually say, hey, if I get more than 3 of these things, then just use this other larger thing instead for example, CSS libraries where you have chunks of CSS and then you just have one version that contains everything. I don't believe that's very well developed, but if somebody wanted to do a little open source project, kind of making that smarter would be a cool one. And I think kills anybody who gets through this course. This is kind of a cool little system. It does its thing and makes handling JavaScript much less of a pain in the butt, because you can just do a requires wherever it's actually going to be used, and then it'll happen. So if you have an inclusion that draws some chart, and then you're going to need the C3 library to draw the chart, you just do a requires inside the chart's inclusion and forget about it. Okay. Questions about resource handling and resource inclusion? Sessions. Session handling is pretty straightforward. If you simply load the library http/http session, you will get, and I'm right down at the end of it here. I'm going to talk about JavaScript, and that'll be it. Okay. So I'm just going to run over just a little. If you run into, if you'll just load this thing, you will then get a session for everybody who visits your site. You can look in the docs and you can control that so that for example, so that sessions are made manually, if you wish. You can set the session options. Okay, let's go back here, and I am going to look at /sessions. And okay, it calls me beloved friend. An affirming web page. Beloved friend, we are glad your spirit is with us. And if I reload this, it's going to remember that I'm beloved friend. Although it's got like a list of things it could call me. But as long as I maintain a session, I'm going to be beloved friend. And it would keep that until I restarted the server or I let my session time out. If memory serves, sessions time out by default in 5 minutes. You can set that in the session options, which you can, there's a call to set session options. Okay, so how does this thing work? If you run this, you may get called something else, but whatever you're called is going to be consistent. Yeah? Is there somebody out there who got called something else? So, okay, so what happens? Well, I call a reply HTML page, and it's going to just make a little web page. And I use the format. Remember, you can use atom minus list to make a format string. And so it gave me a nickname here. All right. Well, you can call HTTP session data, and all right, wise soul, yes. So, okay, so the HTTP session data will just bind to, if you assert some session data, then it will, you can query it by unification. So here we've got it binding to nickname, and then there's where I get the nick back out. And then once I have it, I don't want to have it go back and look for it again. Yeah, if you start a incognito window, you can get another session. Okay, and then, well, if we don't have it, we're going to have to pick one, right? So I will grab the list and then grab a random member out of it. And then I will call HTTP session assert. And then there is an HTTP session retract all as well. Might just be named retract. I haven't done that in a bit. So that's how simple sessions are. They just kind of do their thing for you. All right. Okay, I'm running over just a little. If you gotta leave, you gotta leave. But I'm going to talk about the last thing, and I'm just basically going to relatively briefly mention it because JavaScript. There is a JavaScript Quasiquoter. So if you need to dynamically generate some JavaScript, you can use the Quasiquoter. If you are handling JSON, try to represent your JSON as dicts, even if they're like nested dicts in the on the Prolog side, and they can have arrays or have lists and what have you in them, because there are good facilities for converting between dicts and JSON strings. So writing JSON-based REST handlers is pretty trivial. Really, the old way of dealing with JavaScript was more complicated, but it's not. It's only of historical interest at this point. Okay, and that actually ends my material. Questions? Comments? Feel like they have a bit of a handle on the web framework? Tried more than one way to learn about the web framework, although honestly my online web tutorial on the Pathways site is effectively almost has become the documentation on the subject. Most people are using that. Comments? Great. Okay. Yay. Yeah, Alexa. Okay. All right. Any other comments? Yeah, the web framework's very nice. I love web programming with this thing. And I came into this really kind of hating web programming and fell in love with the. I think I'm the person who originally figured all this stuff out. Jan often prefers to build rather than document. I end up going along behind documenting. So, cool. Glad that was helpful. I will see you back on the Moodle and on the Slack channel. And I think we're out.